to Ally PLM's LunchBytes, What's New in Solid Edge ST8 Part 2. My name's Nathan Pfeiffer, and I'm an application engineer with Ally PLM. Today we'll be covering a few different new enhancements to Solid Edge ST8. First, we'll start with a few welding enhancements, and how they've really streamlined the process of creating weld beads inside an assembly. Next, we'll look at the enhanced digital mockup tools. Following that, we'll take a look at the drawing enhancements that have been added to Solid Edge ST8. Then we'll talk about the drawing compare tool, and this is a great new tool inside of Solid Edge ST8 that we're really excited to introduce to you. Then we'll talk about enhanced electrical import tools, and then we'll wrap up by discussing enhanced electrical routing. Again, the first thing we're going to cover today is the welding enhancements that they've added to Solid Edge ST8. What you'll now be able to do is apply weld beads as a part for greater welding flexibility. This was requested by a lot of different users throughout the industry to be able to do this, and they finally integrated this into the software. There's also now a streamlined process for duplicating weld beads across multiple parts, which is really helpful as well. You can also easily extract property information in a drawing, which is very important to getting your products to market faster and more efficiently. Let's go ahead and take a look at these welding enhancements inside the software. We'll begin by taking a look at the workbench stand assembly. We'll use the display configurations. We can really focus in on what we'd like to take a look at within this assembly. New inside of Solid Edge ST8 is this great ability to create weld beads within this part environment, though we will be editing this within the context of the assembly. This new capability gives our users a lot more control of weld bead creation through the use of standard weld bead commands, using part modeling techniques, or a combination of both. With the weld beads defined in the part environment, you have full control of the material definition, weld bead appearance, and access to their mass properties, as you'll see here in just a moment. One great benefit of working this way is the availability of assembly components at your fingertips. Notice here you can simply identify the top level components while working in the part environment. And as the weld beads are created, the defined material is applied, making this process very simple, very streamlined, and very quick as well. You've probably already noticed that we only applied the weld beads to one component, but with the use of duplicate component, we can expedite the welding process to other components with ease. Because the welds are their own part, you can also apply a color to them and also of material as well. It's also important for you to be able to efficiently document your work within the 2D drafting environment. Here, the initial view can be placed with a single mouse click, along with the options such as scaling, crosshatch, and so on. It's just as easy to place auxiliary views. A cutting plane is applied to the front view, and from that a cutting plane to other views are created. In fact, a detail view may be needed as well to show a more specific detail area of the design. And not only are those existing display commands very easy to use, but you can also now extract weld bead information directly from the model. Another important feature is the ability to create a customized parts list. This list which documents the components and other valuable information. Notice the parts list has calculated the weld bead weight and cost as well inside of here. And if you decide you want to go back into the assembly and make a change, or this part, for example, inside of the assembly environment, you can do so. For example, if we go back in this assembly and increase the weld bead size between the post and the fixture, this change will be reflected throughout Solid Edge. And here in a moment, as we return to the draft, you can see that Solid Edge recognizes changes that have been made. During the update, the dialog appears telling us that the dimension has been moved, but also notes the weight and cost have updated in the parts list to reflect these changes as well. These great new welding enhancements really improve the quality of Solid Edge ST8. We just saw the great new welding enhancements inside of Solid Edge ST8. I demonstrated how to apply weld beads as a part for greater welding flexibility, as well as the streamlined process for duplicating these weld beads across multiple parts. Then finally, we took a look at how easily we can extract the information from a drawing, such as symbols and costing, with this new weld bead information. The next thing we're going to talk about is the enhanced digital mockup. We'll now see enhanced path relationship options for more realistic marketing animations. Also, we now have drive motors that are run from the variable table for better design validation. Then, on-the-fly subassembly relationship override tools, as well as Solid Edge ST8 now supporting more efficient .wmv output support, which is very important for a lot of these animations. So let's go ahead and jump inside the software and take a look at these new tools. Now that we're back inside the software, we can take a look at how Solid Edge ST8 has made a lot of advancements in the area of digital mockup. We used this armadillo assembly in What's New in ST8 Part 1 a few weeks ago, but we'll take a look at it again. Depending on the terrain, this robot may need a different kind of tread, so we can really quickly change our focus to the area of the drive system. You can see that there are belts that have already been added, but we also need to add tread to the assembly. With this tread part, we can use both the belt and an assembly sketch as our path to follow along. New in Solid Edge ST8 is the ability to apply a path relationship, which allows you to set the origin, but also create an offset, giving you full control of part placement along the path. This is a great and very powerful tool in Solid Edge ST8, and we're really excited to have the ability to use it now. You'll now also have the option to flip the direction for the path and set the desired offset, making this a very flexible process. In order for us to replicate the tread around the belt, we use the pattern along curve. Obviously, this command offers several options to help you achieve the pattern you're looking for. But a new option within inside of Solid Edge ST8 is the ability to create a chord length pattern, which gives you the correct results when tracking a squared edge part around a curve without having to create construction geometry. Of course, we need to tread both sides, so we will also define a second curve path to offset the pattern to the other side. Again, having these great new tools inside of Solid Edge ST8 makes this type of work very quick and easy. We mentioned digital mockup earlier and the tools we have used so far to help us set this up. Because we want to synchronize the belts with the wheels, we can quickly set the driving variables to be equal. Notice here, we'll set the tread variable to drive wheels, which sets its value to 300. Then, to simulate the treads rotating around the wheels, we need to set up a motor to drive these components. For ST8, we've added a new motor allowing us to drive values from the variable table. When we run the command, select the variable, give it a speed and a limit, and the variable table motor is created. Excuse me. You can now see how easily it is to drive components from the variable table. Well, let's take a look at another new capability offered to help you promote and use adjustable assemblies inside of Solid Edge ST8. As we change our focus to the top of the robot, you'll notice we place two of the same mini-arm sub-assemblies. Once made adjustable, we now have the option to override relationships, which basically moves the selected relationship to the top level assembly, giving us full control of those relationships. Again, this is a very powerful new feature inside of Solid Edge ST8. To better understand this, let's go back into the variable table where we can set up a quick formula to drive the same angle for each arm in different directions. Using the same technique as when we drove the tread with the variable table motor, we can also drive these arms. You can see we have already created a variable called arm lift, which we'll use in our formula for each angle relationship. Basically, we will place a custom formula for each of the two arms, but notice each arm can be driven independently. Once set up, we can easily change the arm lift value, but notice that each arm is moving in opposite directions. Again, here we'll make a few more adjustments to make this work as it should. Powerful tools that provide the flexibility needed to get the job done right the first time are awesome to have, and Solid Edge ST8 gives us this ability. Now, using the new variable table motor command, we can also set these arms in motion. To better visualize these parts in motion, Simulate Motor lets you set up and run your animation using motors that we defined in the last few minutes. Once in the timeline, many tools are provided to help you simulate your designs. For example, you can reverse the direction of the motors or simply copy and mirror them to get them to move in both directions. Then, you can just hit play to see the results. Let's take a look at our results using these sub-assemblies. If you like what you see here, you can easily save the simulation as a movie in AVI or WMV format. Solid Edge has made a lot of great advancements in digital mockup, as you can see right here, and we're excited to show you those to you today. Once again, we just checked out the enriched digital mockup inside of Solid Edge ST8. I demonstrated enhanced path relationship options for more realistic marketing animations, as well as how to use drive motors from variable tables for better design validation. We also took a quick look at on-the-fly subassembly relationship override tools and our efficient WMV output support. The next thing we're going to talk about is a few drawing enhancements inside of Solid Edge ST8. These will include advanced dimension and annotation handles, new interface for format values, unique parts lists and ballooning for subassemblies, which is great for large assembly drawings, as well as link property and reference text and text boxes for automation, flexible thread dimensioning, and technical requirements text. Let's go ahead and jump inside the software and check out all these new great enhancements. back inside the software, we can see the great new drawing enhancements inside of Solid Edge ST8. To start, you'll notice when clicking on the dimension, we have all these different handles. This handle that I'm clicking on now allows us to extend the gaps for the dimension extend lines. Notice this dimension here is off center, but when we start to drag a new indicator, it shows us the center location. Again, we'll click the other two handles to change those lines. With these handles, we can increase the gap around the dimension. Center handles allow us to quickly move the dimension. If we insert a jog into a dimension, this indicator allows us to quickly remove the jog if needed. Here, all we need is to move the dimension down. The diameter dimensions also have editing handles. If we drag the dimension handles, you will see that we can simply move the dimension. Dragging the handle on the brake will move side to side and extend the length of the brake without going into the properties. Notice as we highlight all three of these dimensions, they share one common extension line. Moving the extension line will not only move the selected dimension, but moves the other two extended lines at the same time. This is amazing user experience and time-saving technique. This dimension here can stay in the middle, but the arrows need to move outside, and now with a simple click that's very easy to do. Need to change the arrowhead style? That can be simply done as well. Turning on and off extension lines has been improved, so no more property box for that either. Annotations have the same types of modifying handle as dimension. Let's take a look at a few of these annotations. The center handle here on the finish symbol moves the symbol around. The midpoint handle flips the side the symbol is located on. The end handle extends the length of the brake line. Balloons work the same way, but notice here that when we start moving the balloon, we get this indicator to locate in 45-degree increments. If we have a brake, you will get the indicator at the brake. Moving the brake displays the indicator at the arrowhead and on the brake line. Knowing the correct syntax for Unicode has been challenging in the past with Solid Edge. With whole definition, we can now add things like dual units without knowing what the syntax should be. As I said before, this was definitely a challenge in Solid Edge previously, but these great new enhancements make this very simple to do. Also, rounding is done with just a simple drop down. On this dimension, we want to add some tolerance to the dimension with upper and lower limits. This dimension has a date, and with the format command, we can choose from the list of different ways to display this date as well. But first, we'll change the upper and lower tolerance and show how that's displayed. Again, you'll notice that there's a date there. Here, with just a simple drop down, you can change the way it displays. Notice now that the day and month are in lowercase. We actually have options to control this now as well. For this example, we'll make it all uppercase. Also, Also new in Solid Edge ST8 is the ability to have a parts list of a sub-assembly on the same sheet as the top level assembly, and the sub has its own unique item numbers and balloons as well. Just that quick and easy, we have a parts list of a sub-assembly. Solid Edge also has the ability to link reference text together, like here with these symbols. You'll see how they both reflected the change. Solid Edge can also link a callout with either a property text or reference text. When the symbol is changed, it updates in the callout. Again, this is a very powerful new tool inside of Solid Edge ST8. Hole callouts for threaded holes has always dimensioned to the minor diameter. Now we can also dimension to the major diameter. Next, we'll have a new type of callout called technical requirements. Technical requirements are those special notes that we need to add to a drawing as a numbered list with numbers or Roman numerals to point out specific details about the drawing. Here we'll add 3 different types. First, all dimensions must be checked, stamp part number here, and glue all areas. We'll use as our 3 examples. Linking reference properties to the technical requirements is quick and easy. We do this to ensure if a note changes, then the callout will also update. "2D drawings are a very important part of the design process. With the enhancements inside of Solid Edge ST8, Solid Edge's drawing environment has become a very powerful tool. Once again, we just covered the drawing enhancements inside of Solid Edge ST8. We started by showing advanced dimension and annotation handles, then the new interface for format values. We also took a look at unique parts lists and ballooning for sub-assemblies, which again was great for large assembly drawings in our example. We also looked at linked property and reference text in text boxes for automation, flexible thread dimensioning, and the new technical requirements text. All of this is great new functionality inside of Solid Edge ST8 that really improves the 2D drawing environment. The next thing we're going to look at, and the thing I'm personally most excited about, is the Drawing Compare tool inside of Solid Edge ST8. This has been a requested enhancement for many years now, and we're very excited to have it in this release of the software. The Drawing Compare tool can quickly and easily compare drawings. It has interactive interrogation with color coding for clarity, and save comparison for future reference as well. This is a great new tool, and let's jump inside the software to take a look at how it's used. When working on design teams, there's certainly times when someone could open a model and make changes to the model file without ever really considering the manufacturing drawing. Then someone else would open the drawing and notice that it's out of date. When this happens, there isn't really a good way to know what has been changed. Solid Edge ST8 now has a new tool called the Drawing Compare tool that lets us see what has been changed by the model by comparing the 2 draft files of the same model. Let's take a look at how this works. Let's make a change to the model by moving this boss to the right. Now up here on the top, maybe we need to increase the size of this face. Again, we've done both of these two moves by simple synchronous edits. Now let's go and take a look at the drawing of this model. Here, as I mentioned in my example earlier, you'll notice that all these drawing views appear out of date. So therefore, we need to update the drawing views. We don't want to overwrite the original drawing, so doing a save as allows me to keep both the original drawing and what has been changed. This is done by simply changing the name of this draft file. The new Drawing Compare tool allows us to select both the original and the modified drawing. Selecting the Compare button inside the Solid Edge option allows us to open the two drawings in the bottom windows, and the top left displays the differences in the two drawings. This is done by simply browsing out and finding both the two drawings we'd like to compare. The top right window shows information about both the two files. Draw Compare has tools to zoom window, fit, pan, and zoom in and out. When doing this in one window, it will do the same in each other window. File 1 is in the left window and has a default color of green to show the items in the before state, before our changes were made. File 2 in the right has a default color of blue to show after the changes. Here, at first we can see the bosses in a different location, and we can check the back edge as well, that we can see the increased face width. If we zoom up around the two bosses, we can even see the before and after dimensions of each boss. Then we can save this comparison to review it at a later date. At any time after saving, we can go back to the compare file to see the changes without having to browse back to the two different file locations. The new Drawing Compare tool is a quick, easy way to ensure our changes are correct changes. This is a great new powerful tool inside of Solid Edge ST8. I just showed you the new Drawing Compare tool in Solid Edge ST8. We saw how quickly and easily we can compare drawings that have changes in them. We have interactive and interrogation with color coding for clarity. We also have save comparison for future reference. Again, the Draw and Compare tool in Solid Edge ST8 is a great new tool that we're excited to introduce to you. Our next topic is our enhanced electrical import options. Now, immediately know when multiple occurrences of the same connectors are present. Also, we have quick and easy selection of the correct occurrence. And finally, we have new visual feedback of import validation, which we find is very important. Let's go ahead and jump inside the software and check out these new electrical import options. One of the key focuses for Solid Edge ST8 from the developers has been in the wire harness creation and routing. We've been working with a prototype robot and are going to reuse some of the same internal electrical system design as in our current manufactured version. Here we have our new layout of all the physical components. We're going to import our wiring schematics now. Opening the harness wizard, we can select which electrical package format we'd like to use. We're going to import a schematic built from Zuken E3 software, for example. Here we'll quickly select our connector and component files defining our wire runs. Once we import our components and connector files, you'll notice that Solid Edge is going to need some feedback as far as what to associate with the E3 schematic. It's telling us here that we have multiple identical components. We need to define which instance of each to associate to the wire schematic. This step makes for identifying and selecting occurrences of components and connectors very simple. Additionally, since our robot design has slightly changed, we have two occurrences of our converter where previously we only had one. While we're in this step, notice the highlight for the selection step only works on parts that aren't already defined. This workflow enhancement makes it easy to define which occurrence you wish to associate to the connecting wires. Once we've selected all the components to be used, Solid Edge offers us the same great readouts of wire and cable definitions to convert over our 3D representations. With the new component selection options available in Solid Edge ST8, importing wire harnesses is a breeze. We just took a look at the enhanced electrical import options for Solid Edge ST8. Now you'll immediately know when multiple occurrences of the same connectors are present. You have quick and easy selection of current occurrence, and visual feedback of import and validation. All these new things make importing electrical wires a breeze. The next thing we're going to talk about, and the final thing, is enhanced electrical routing. Now you'll have persistent PMI for efficient routing, route imported cables through clips and other part geometries for accurate packaging, the ability to split and reuse existing paths to easily create custom bundles and cables, and splice wires and cables to fully represent any wiring schematic. Now we'll jump back into the software for one final time to take a look at this enriched electrical routing. Now that we've imported the wires and begun to create a physical harness out of them, we need to add some finishing touches and route the electrical wires on this side of our robot. We've changed out the motors on our prototype, so our first step is going to be defining them as electrical components and assigning the terminals. New to Solid Edge ST8, all definitions and terminals can be created as PMI annotations. By checking that button for Create PMI, this allows users to label them in the part, but then read them in their information on wire creation and routing. Now that all of our components are defined, we can now go to our harness creation tools and begin routing. The first step shows an existing cable that was brought in through our wire import. Rather than having to create custom paths to route through, Solid Edge ST8 has a new command allowing users to utilize existing clips to route wires and cables through. Notice that the routing orientation is not what you're expecting. We can simply press F to flip the direction of the route. Users also now have the ability to associate any circular faces, including partial rounds, in their selections to create the desired results. Once we've got our longest cable placed, we're going to utilize an existing path created to bundle other wires into the harness. Another new capability in ST8 is splitting paths. Notice how selecting a path in an area that doesn't already have an associated control point adds a blue dot. Placing our first split across from our motor terminals and our second to the control point on the edge of the clip allows for an input and output for new wires to be bundled. Notice that the routing a 3D sketch allows us to easily get our desired results in a fraction of the time. Using the control point and blue dot created on the splitting path makes an appropriate anchor point for our two new paths to complete the run. Using new paths that connect to a split allow users to bundle several runs together to create a desired harness. Now our path that's in this place, it's time to create our wires. Using new Solid Edge ST8 options, we now have the ability to pull our PMI information that we created earlier. Selecting our component information option, we can quickly see the terminal layout and appropriately create new wires. Additionally, new filtering options with the wire creation command allow us to not only look at defined terminals in order to narrow down our key point selection options. This is going to save a lot of time in selecting exact terminal geometry. Knowing how we plan to bundle the wires gives us a good idea of the directions they need to go. And using Solid Edge routing capabilities, we can put everything in the proper direction. Of course, if you ever need to change it around, editing wires and paths is very simple, as you can see. Now that our wires are in place, all that's left to do is bundle them. Allowing for paths to be split and reused allows for making harnesses and bundles that not only represent appropriate location, but Solid Edge also can calculate the diameter of the cables and bundles based off how many and what size wires are running through them. Here we're simply going to change the color of the newly created bundle to differentiate it from the others. Creating physical conductors gives real 3D representation of wires and allows us to see exact sizes in an associated model. Once rooted, notice that our bundle is associated to the geometry used for creation. We split the path along the clip center point. For our final routing task, we need to wire in our second converter component. For this, we need to splice our new wires into the existing cable. Using ST8's new splice command, we can easily define which wires we want to splice, or in this case, an entire cable. There are several different splices available to be represented, and here we're just going to use a simple barrel slice. A sphere is created to represent the splice feature, in which we can now route new wires, or if the situation is called for, even remove a wire. We can quickly place the wires necessary using our terminals for our anchor points and splice features as the endpoint. Quickly creating our wires to join to the splice, we've completed all of our necessary routing tasks. As I finish up here, you can see routing in Solid Edge ST8 is easy and intuitive. Using the new route through part command, wire creation options, path splitting and reuse capability, and allowing for physical splice representation saves time and hassle, even on the most complex of wire harnesses. This will help speed up the design process. We just took a look at ST8's enhanced electrical routing functionality. This includes persistent PMI, route importing cables through clips and other part geometries for accurate packaging, split and reuse existing paths to easily create custom bundles and cables, and finally the ability to splice wires and cables to fully represent any wiring schematic. To recap what we've seen today, we took a look at the welding enhancements new to Solid Edge ST8, as well as the enhanced digital mockup, all the different drawing enhancements, the brand new drawing compare tool, enhanced electrical import options, and enhanced electrical routing. All of this makes Solid Edge ST8 a great new product. Finally, I'd like to thank you for your time today. Hopefully you learned some valuable information about what's new in Solid Edge ST8. If you have any questions, please let us know. Thanks, and have a great day.